I love math. Get ready. Go.
I love math, and math loves me.
It says
CCS 1, 2, 3.
Watch and you will see. All right. So, boys and girls, yesterday Mr. Narvaez ran off in a hurry, and Ms. Tennell and Mr. Narvaez got together at the end of the day to talk about some of the big ideas that all of you mentioned. Because yesterday we were talking about area. We were talking about
Area.
What's area? Who can tell me what area is? What's area? Eyes on Neil.
Area is the space inside a 2D shape.
What is area, everybody? Area is the
Space inside a 2D shape.
area is the space inside a 2D shape, and that was one of the big ideas that you all took away yesterday when you were finding area of what kind of shape again? It was what?
Rectangle.
But you all didn't just tell me what area was. You gave me some really great ideas that I want you to keep in mind as we get started today, okay? So one of the things that you all mentioned was we can find area of a rectangle by using square units. By using what?
Square units.
And remember, those units might change depending on what we're measuring. What are some units that we use to measure? What are some units that we use to measure? Give me one, Adi. Start us off. What do we think?
Yes.
Hold on. Go ahead.
One measurement we use when we measure meters.
What do we think?
Yeah.
Say you go, dude.
You go do.
What else? What's another unit of measurement? He said meters. Adi said meters. Give me another one back here. Freeze. Can you hear her? Say loud and proud.
Loud and proud.
Go ahead. Is inches. What do we think?
Yes.
Say you go, girl.
You go, girl.
So we have inches, meters. Give me some other ones. Hayden, give me one.
Another one is yardsticks.
Yards. What do we think about that?
Yes.
He said yardsticks, but he means that's the actual tool that we use, but he means yards. What do we think about that?
Yes.
Say you go, dude.
You go, dude.
What else? We had yards, meters, inches. What else? Over here.
Another measurement is feet.
What do we think?
Yes.
Say you go, dude.
You go, dude.
Last one, and I know we could keep going on and on. Last one, Vincent.
Another measurement that we can use is centimeters. Yes.
Say all right.
All right.
Eyes up here. So we had a couple of big ideas that came out of yesterday's lesson. One was that area is what again?
The space inside a 2D shape.
So the space inside a 2D shape, we said that we can measure area by using square units, and you all just named some of the units that we could use. And then we had these other two big ideas. One is that we can use our knowledge of rectangles to help us find area. What knowledge are we talking about? What are the things about rectangles that we're talking about when we say we can use our knowledge of rectangles? Turn and talk with the person next to you.
How much size the sides are? The sides are like each side sides are every pie is it's the same size, so there's no
What do we know about rectangles that can help us find area? What do we know about rectangles that can help us find area? Eyes on Vincent. He's going to give us one thing. Maybe you have something else you're thinking about. Is he right? Do I agree with him? Can I build up? Go.
All sides are not all the shapes of
All the sides of a rectangle are not even. I see some disagreement. Talk to us. Go ahead.
I disagree with Vincent because
What do we think?
Yes.
Tell me why. Tell me how you know. Prove it to me. Neil, go.
I would like to add on to Marshall's thinking by saying that both the parallel the top and bottom sides are parallel and the right and left sides are parallel and both of those sides are the same length.
Neil, you're saying parallel. Tell me. I don't know that everyone has heard that word. What do you mean by parallel? Go ahead, Neil.
Parallel means that those two lines will never touch each other.
Those two lines will never touch each other. Take a look up here at one of our rectangles. Neil is saying this top line and this bottom line will never meet. They're never going to meet. We call those parallel. What do we call them?
Parallel.
And we know that those two sides are opposite from one another. They're on opposite sides. So what you all are saying that can help us with area is that opposite sides are the same. What are they?
Opposite sides are the same.
And that will help us determine area. And here's the last big idea from yesterday, and we'll move on. Because there's one idea that we missed yesterday, and we just want to make sure that you get to it. The last big idea was we can use repeated addition or multiplication to help us find area. I want you to think about why. Why can we use addition, repeated addition, or multiplication to help us find area? Turn and talk.
If you multiply these on the side, you get the pyramid
Again, I'm going back to this idea from yesterday that you all came up with, and you said we can use repeated addition or multiplication to help us find area. I'm wondering why. Why? And use your knowledge of what area is to give us this explanation. Let's start off with my friend here. Tell me your name. Sohan. Sohan's going to start us off because he said something that was interesting to me. He's going to start us off, and then I don't want the conversation to end. I want you to build off of what he's saying. Go ahead.
So you have to do addition or multiplication because if you don't do either of those two, you will get your total space inside the 2D figure. So that's why you have to like add, or you could multiply if it's easier for you, so you could get the total space of the inside or total areas.
Go ahead, build off.
And I want to add on to
So I'm hearing that all of you are saying we can use addition because we're trying to figure out how much space total is inside. And I'm hearing this idea that we can also use multiplication because there's a connection between multiplication and addition. Go ahead, build off.
I would like to add on to both of them. Like, you can either add the rows and columns. You can either multiply the number of rows and the number of columns, or you can add the number of you can add the rows like as many times there is the columns. So if there are six rows and 8 columns, you could add 8 times, or if there are 8 columns and 6 rows, you can add 8.
So that's similar to this one of these strategies that you all shared out yesterday. You all said, well, I could count every single unit, right, every single tile, and add them all up, and that's going to give me the total amount. Or I can count how many are in each row, and then add that number over and over again to get my total. Which some of you also said, well, that connects to multiplication. I don't have to add every single row together. I can just use multiplication. So there were a number of different strategies that we used yesterday, and I want you to keep those strategies in mind as we look at some shapes today, okay? What do you notice here? What do you notice here? Tell your partner. What do you notice? Start us off, Maya. Tell us what you noticed about the shapes up here.
It's like a rectangle like that, and then it's another rectangle on top of it. So you can like measure one rectangle on top of it, and then measure the other one on top.
Bill.
Finish your sentence. Finish your sentence, Maya. What
Do you
was
have
the
any other
last
thought?
No. Well, you can like add both of the legs together to get it.
Who can build off? What else do you notice? So far we already have some thoughts about this type of shape. We said it looks like two rectangles that have been combined. What else? Yes.
In the first one, all the numbers.
Oh, in here all the numbers are even. Okay. What else?
They're not parallel lines.
Huh. We don't have parallel lines. Do we think that do we agree with that completely, or do we partially agree with that?
I disagree.
Tell me why. Tell me why. Adi,
There are parallel.
can you show me? Come up here and show us. What lines would you consider parallel? This one and this one, right? Because we know for parallel lines, they will never meet. And so, technically, this line could keep going, right? All the way across. And this line could keep going all the way across. Will they ever meet? How do I undo? Okay, so we said we have some parallel lines. We said that these shapes look like rectangles. Are you ready for your challenge?
Yes.
I don't know if I believe you. Are you ready for your challenge?
Yes.
Your challenge today is to find the area of these two shapes. And we'll talk about a little bit later what kinds of shapes these are. But I want you to use all of your knowledge, all of your ideas, about finding area. Okay? So when I say go, not yet, you're going to stand up, you're going to go back to your seats, you are going to pass your papers down, name and date, and get to work on these two problems. That's problems number 1 and problem number 4. 1 and
4.
don't worry about any of the other problems on the page. We just want you to work on these two problems. Okay?
One is on the front, one is on the back.
Yep.
Stars next to that.
Stand up. I want you to try this independently first. Good thought. Thank you, Adi. Independently first, and then we'll give you some time to work with partners. Go. Hands and eyes? Hands and eyes? Okay. Here's what we're getting ready to do, and I need you guys to do this super quickly. So you're going to leave your pencil. Just bring your paper back. Hold on. Just bring the paper that you were just working on to the meeting area, and you're doing it quickly, silently, and safely. Go. Okay, so we're getting ready to have a math talk, and so this is what I need you all to do. First of all, we don't want our papers to distract us, so put your paper in front of you. Make sure it's flipped to the side with question number 1 on it, because we're looking at that one first. Question number 1, because we're looking at that one first, and then hands in your lap. Rajveer is going to start us off. And boys and girls, we are listening to what Rajveer has to say. Take a look up here. So this is the shape, and it's the same as this shape. I'm going to use Rajveer's strategy up here. He's going to walk me through it. While he's walking me through the strategy, I want you to think, is this similar or different to my strategy? What's similar or different about it? What ideas do you have about that strategy? And we'll discuss it, okay? So Rajveer, tell us about what you did, and I'm going to ask you to share out why you did it. What did you do first?
So first I made a line across the other square up there.
And why did you do that? So you made a line right there. Why did you do that?
Because because if I would take that shape out, I would get an equal rectangle. So then I would make that before I would make it.
What do we think about that? What did we use our knowledge of when we cut this shape here to make 2 rectangles? Adi. Yeah, so we used our knowledge of rectangles, parallel lines, and we said we're going to cut this here. What did you do next, Rajveer?
I saw 2 times 2, so I know that 1 times 2 is 8, so 8.
But what did you actually do on your paper before you did 2 times 2? Because you did something different.
Yeah, I counted
So he counted all of the tiles. He said 1, 2, 3, 4, and how many square units did you get up here?
4.
So then he got 4 units, 4 squared centimeters here. Then what did you do?
Then I counted all those other squares.
So 1, 2, 3, 4, 5. You're listening and thinking, is this strategy similar or different? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 30, 31, 32. Then what did you do?
Not 36.
Oh, because you continued counting. So you said 4, then you said 5. But what can I do?
And then I add.
So if I have 32 down here, and I have 4 up here, I can add them. And what number would you get? You just said it. 32 plus 4. 36. 36 centimeters squared. Or square centimeters.
Excuse me, can you send Darshini to the office to pick something up?
Sure, she's coming.
Thank you.
So Rajveer counted up all the units. Why does that strategy work? Why does that strategy work? And if you had a similar strategy, tell me, why does this strategy work? Hayden.
The strategy works because I did something a little different than him.
I want you to tell me about why this strategy works.
The strategy works because it's very simple and it's also something that you can think of very quickly.
What do we know about area again? Area is what?
The space inside a 2D shape.
So if we're looking for area, why does Rajveer's strategy work? Go. There are no gaps or spaces. Did he count up all of the units inside of the shape?
Yes.
Okay, so now let's take a look at Maya's strategy. She had a little bit different of an approach. She's going to walk me through her strategy, and we're going to compare the two. Go ahead, Maya.
Okay, so I did the same.
Loud and proud. Tell me what you did
I
first.
put a line with that one,
Okay?
and then I marked the column.
Okay? This one here. Okay. Oh, I see what you're saying. Okay, so she went down here and she said 1, 2, 3, 4, 5, 6, 7, 8, and then she said 1, 2, 3, 4. Why did you do that, Maya?
So that I could hit 8 4 times because the row has 8 and then the column has 4. So
The column has 8, the rows have 4.
and then so there's 8 in each row, and then there's 4.
Can you give me a number sentence that matches? 4 rows, 8 in each row. You said it a little while ago. 4 rows, and there's 8 in each row.
8 times 4.
Does that match 4 rows and 8 in each row? What would match 4 rows and 8 in each row? 4 times 8. And we know, Maya, we're going to get the same answer, but I wanted to make sure that it matches what you did. So 4 times 8, and what did you get, Maya?
I got
32, and then
For the square, I put 1 and 1, and then I plus that, and then I get 4, and then
So she had a different strategy, but I want you to think about what was the same between these two that we can take a big idea away from what we just did. So I want you to think about what was similar about what they did and what big idea can we take away from their approach. Turn and talk with the person next to you.
She did put numbers in every single box, and then she only
What did they do that was similar or the same? Okay, but what did they do that was exactly the same? Did she count all of the spaces though? Can you say that one? 3, 2, 1. I actually was out to get one big idea, but I'm hearing more than one big idea, which is excellent. So start us off with your big idea, and then I'm going to go over here because I heard something happening over here too. Go ahead.
So,
What did they do that was the same?
the same thing they did was that in the end, Maya did
In the end, or you
Yeah.
didn't say in the end earlier, you said in the beginning. What did they both do?
In the beginning, both of them divided
stop right there. What do we think about that?
Yes.
Okay, so moving forward, we have these shapes, and I'm going to actually tell you the name of these shapes now. These shapes are called rectilinear shapes. Everybody say rectilinear shapes.
Rectilinear shapes.
And a rectilinear shape, well, first of all, this is the word up here. What do you notice in the word? What do you notice in the word that can help you determine what you think it might mean? Yes.
I'm hearing the sound of
And what words do you know like that? Everybody should know this. What word do you know like that?
rectangle.
Rectangle. And so a rectilinear shape is actually a shape where all of the sides meet at 90-degree angles. When you get into 4th grade, you'll talk about angles and their degrees, but basically the corners meet. Just like in a rectangle, where all the corners meet at a 90-degree angle. And so what you're telling me about finding the area of rectilinear shapes is what? Where did they both start off? Where did they both start off?
At the top.
And what did they do?
They made a line.
And what did that do to the shape?
So what they did was that they got 4 and then they started.
Hold on, freeze. When they drew that line, what did it do to our rectilinear shape? It divided it. It broke it down. There's a word that I think you used before earlier on this school year. Does anybody remember when you break something down or apart? What is it called in math, Adi?
Decompose.
Everybody, it's called
Decompose.
So you're telling me, based on what we did here, you're telling me that when we're finding the area, of rectilinear shapes, what do we need to do? What do we need to do? We need to decompose. Everybody, what do we need to do?
Decompose.
Here's my question though. Can I just decompose this shape in any way that I want? Like maybe a line like this?
No.
Why not?
Because you're not decomposing it in equal shapes, so it would be like sloppy. Yeah, it would be like hard to measure because you can't because it's unequal. So then.
Why is it hard to measure? I want us to think a little bit deeper about that. Why is it hard to measure? What helped us measure when we decompose? What helped us measure? Yes.
So it's like it has equal sides, so it's easier to measure. You don't need to count the uneven.
And what did we use our knowledge of to say, when we broke this up, we want to break it up a certain way. We can't just break it up this way. What did we use our knowledge of? I'm going to this side of the room. What did we use our knowledge of? Rashmir.
We use our knowledge of the shape.
What shape?
The rectilinear.
So, to break up the rectilinear shape, we use our knowledge of what?
Rectangle.
Of a rectangle. What do we use our knowledge of?
Rectangle.
So, one big idea that you're getting from this is that we can find the area of rectilinear shapes by decomposing into rectangles. So I want you to think about that as you move forward. Now I heard another big idea sort of coming out of a conversation over here. And what is another thing that you found that both of these strategies did? Both of these students did. What did they do? I'm going to go over here and then I'll come back over here, Aiden. Go. They both counted. Did they count exactly the same way?
No.
But what did they both do?
They got the same answer.
Okay, they got the same answer. So they found, go ahead. They multiplied and added. And why does that work? Did they both multiply?
No.
Did they both add?
Yes. 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 Yes.
Freeze? Freeze? when they looked, who was this, Rajveer? When Rajveer was trying to find the area of this entire shape, he broke it up, and first he found the area of this part, and then he found the area of this part, and then what did he do? When Maya broke up her shape, she multiplied and found the area of this shape, of this rectangle, and then found the area of this rectangle, and what did she do?
She multiplied then added.
Turn and talk to the person next to you. Why does that work?
She multiplied then added the area like that shape over that's four and that. Strategies where he counted up every single tile and added it together, or where she counted these tiles, found the number of rows and columns, and then multiplied and added together. Why does it work? And think about your knowledge of area. Adi. It works because if you see on that chart, Rajveer did the one when he counted all the strings, but instead he made the line. He counted both of the rectangles. The first rectangle, then he took the square, then he counted all four boxes, and then he added them together, and that worked because he counted all the squares in the whole shape. And
hold on, because you just said something really important. Did Rajveer count or use all of the space inside the shape?
Yes.
Did Maya count and use all of the space inside the shape?
No. Yes. A bit. Kind of. Just a bit. Only for the.
Let me restate my question. Did Maya account for all of the space in the shape?
No.
So he counted every single space. Did she count every single space?
No.
We have some debate here.
That's Maya.
Freeze. So let's do something for a second. Maya said there's 8 here, and there's 4 columns here. When she multiplied, what did she actually do? Yes. So you're saying she added all of this space? But I thought you just told me she didn't account for all of this space. What do we think? What? Tell me. So how did she add? What did her addition look like? So his addition looked like this. 1 plus 1 is 2, or 1, 2, 3, 4, all the way until he got to 32. He added each of those units all the way till he got to 32. What about hers? What did hers look like? But when she multiplied it, did she end up counting all of the boxes?
No.
Someone who's saying yes, tell me why you think that. So if we're multiplying and I'm counting all of these boxes, like Rajveer did over here, am I going to get the same answer? Why? Why? My friend who's next to tell me your name again. Darshini. Why?
You will get the same answer because she cut up the same part. So Roger left 4 and Maya left 4 on top. And Roger just counted the shape, but Maya multiplied, so you would still get the same answer from the bottom. And then if you add the top 4, you would still get the same answer.
So boys and girls, Maya still counted. She didn't count 1 by 1. She still added. She didn't add 1 by 1. She added in a different way. What does her addition look like? She has 4 times 8, but what does her addition actually look like?
40 times.
So what does that look like? Tell me the addition number sentence that she used. Yes.
4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4.
Does that match our multiplication number sentence?
Yes. No. No. No.
Freeze. Let's think about what we know about multiplication. The first number represents what? The groups. Everybody say groups.
Groups.
The second number represents what?
Objects.
Number in each group. So I want you to think about her groups. She said there were 4 rows and 8 in each row. Here's 1 row, here's 2 rows, 3, and 4. She had how many groups? How many groups?
4.
How many in each group?
8.
What does her repeated addition number sentence look like? In the back. Did Maya account for all of the units in this rectangle when she did that?
Yes. Yes.
We just did a lot of math, boys and girls. And we just walked away with another big idea. They both of these strategies accounted for all of the units in this entire shape by using what? What operation in the end? What operation? Addition. So we needed to add all of this space together to figure out how much space was inside. What do we call that? The space inside. We needed to add all of this space together to find what? Everybody.
The area.
Because area is what?
The space inside a 2D shape.
Whew. We're gonna we're gonna add that big idea here and hopefully very quickly discuss this next problem. So take a look at this next problem, and this is supposed to be Mrs. Cirillo's office, so we changed it a little bit. So knowing what we did with these 2 strategies, take a look up here. We have a rectilinear shape. Someone, who was my friend that was back there? Anviksha. Anviksha, talk to me about what you did, and who's the other person with the square tiles? Is that number 4? Turn your page.
Turn your page to
Turn your page to number
number 4.
4. I just need to look at something really quickly.
Vincent did square tiles also when he started.
Are you on number 4? Okay. Panav?
Yeah, he did.
Panav, you're going to walk me through your strategy first, and then Anviksha, you're going to walk me through your strategy. What did you do, Panav? And you're listening and thinking about the knowledge that we have of rectilinear shapes and finding area. Go ahead, Panav. What did you do first?
For the first one, I
So you drew columns. Did you take your line all the way down?
No, I drew rows.
So you drew a line like this, enough, right? That's making a column, not a row. So how many were in your row?
There was 5 in it.
Okay, so you had, I'm just going to stop it here. So you had 5 units, like that. Okay, what did you do next?
So I looked at the other one, and on the left,
What other one?
it said 3 centimeters.
Okay.
So I knew there was going to be 3 blocks, another 2 blocks going down.
Like this?
Yeah.
Did you bring these lines down?
Yeah.
Then what did you do now?
Then I drew I like cut that the 15 square centimeters off so that it looks
Which
like
one?
a rectangle.
Oh, so then you cut this off here. Okay.
And then I was looking on the bottom, and on the right line it says 7 centimeters. And I already knew that I drew 3 centimeters going down, so I needed to draw 4 more. So I drew that 4 more centimeters going down.
Pranav, I have a question for you. So he drew another line here, and then he drew 4 more. Pranav, you said this was 7, but you already drew 3, so you had to draw 4 more. What else could you have used to know that you needed to draw 4 more?
Because I knew that 7 subtracted 3 is 4.
But what else could you use? So you said you used this side, which is fine, but what else could you use? Yes.
4 on the left.
Why?
Because 3 plus 4 equals to 7, and that's what it says.
So you're saying this 3 up here
Yeah.
plus 4, but why else could we use this 4? Think about your knowledge of what you know.
Because that 4 and that 3 are the same size as that 7.
You're telling me the same thing he told me. I'm asking you to use your knowledge of what you know. Why does this side have to be 4? Why does this side have to be 4?
Ooh, I know my God, because both of those sides are the same.
What sides?
That
How do you know?
one.
She said both of these sides have to be the same. This has to be 4 now. How do you know? Hayden.
I know because all 4 sides have to be the same.
Say that again.
All 4 sides have to be the same.
All 4 sides have to be the same? Is this side the same as this side, Hayden?
No,
So- So what are those sides called that have to be the same? Not all 4 sides. Parallel or opposite sides. Hayden, what sides have to be the same? Everybody, what sides have to be the same?
Parallel.
Or opposite sides. So we knew since this was 4, this also had to be 4. Go ahead, keep walking me through your strategy.
Now on the bottom, it said 10 centimeters. So I had to, so I already drew that 1 centimeter on that row. So I had to draw 9 more.
Okay.
And then since there's like no more like centimeters, since there's no more like measurements, we have to keep on doing that for all the other rows.
I disagree with you. Who else?
What?
What could he also look at? Pranav, I think you did something else to, I know you're saying there's no more measurements, but I do think that there are more measurements that you could use. What else could you use?
I can use that 5 centimeters on top.
Okay, so what would you do here?
I would like put the 5 centimeters.
So 5 columns, right?
And then add the other 5 columns over there.
Across, right? We already had drawn one. Then what did you do?
Now we have since now for the other rows like those blocks over there, we have to make rows for them.
How many rows should be on this side? 3 more. How many total?
There's 4 rows.
Okay. Then what did you do?
Now since it said 10 centimeters, I took 10 centimeters and the 4 rows, which
there were four rows of 10, and so you did 4 times 10, and what did you get?
About 40.
Okay, what did you do next?
Then I added the 15
Where'd you get 15?
from that other part.
From this other part. Where did you get it? What did you need to do to get 15?
I needed to look at how many square centimeters were in the rows, and then see how many rows, and make it I multiply by 3 plus 15.
And then what did you do?
Then I added the 40 and 15 together, and it gave me 55.
And you had a double check strategy on your paper, which is why I initially called on you. What was your double check strategy?
So I
At the top. How did you double check that top?
I counted all the squares.
So to make sure he was right, he said, well, I know 3 times 15. Let me just count just in case. And he said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did he get the same amount?
Yeah.
Okay. Anviksha, walk me through your strategy. Remember, you're thinking what's similar and what's the same of these strategies. Anviksha, walk me through your strategy.
I said split with the top.
This one here?
Yeah.
Okay.
So I multiplied on the bottom. 10 times 4, which is 40. And then on the top of the row, I multiplied 5 and 5 times 8, which is
Where did you get these numbers to multiply? So let's look at 4 times 10. I noticed you didn't have to draw all of these square units to figure out that there were 4 rows and 10 in each row. Where did you get these numbers?
on the bottom of the table. It says 10 and 4.
So if this bottom here is 10, and we've split this shape, what is this top now? What's the measurement of the top? What's the measurement of the top now? Yes. Why? How do we know that? How do we know that this side and this side? What do we know? How do we know that? Use your background knowledge in the back.
Now they are the same size, so parallel sides are the same size.
So Anviksha said, I knew that this side also had to be 10, and what would this side be now, Anviksha? This side here. 4. And how do you know that again, Anviksha? So parallel sides are the
Same.
So 4 times 10 equals 40. Then what did you do up here? Okay. Did they get the same answer? Different strategies though. So here's one thing that I think we're walking away with another big idea. In both of these cases, both students drew in all of the columns, all of the rows. In this case, she drew in the columns and rows, but she only counted or created groups. And in this case, she broke it up and she didn't use columns and rows at all. But why did we get the same answers? Turn and talk with the person next to you. different strategies, and we want to take another big idea from this. We already know that when we're finding the area of rectilinear shapes, we need to break them up, or what's that fancy word?
Decompose.
Decompose them into shapes that we already know. What's the shape that we already know in this case? Rectangle. And we can use our knowledge of rectangle to find the area. In all of these cases, we use different strategies. But I want you to think about why they worked. Start us off, and I want you to think about what she's saying. Go ahead.
The top and top are the same, and the bottom.
So these two shapes are the same, and these two shapes are the same.
The green one on the right and the one on the left.
Yeah, these two shapes are the
Yeah.
same.
And then the bottom is same.
Oh, you're saying these two shapes.
Yeah.
Okay, go ahead.
But they just use different strategies, but the space is the same.
So, tell me your name again.
Darshini.
Darshini, when we were talking, she said, well, Mr. Narvaez, they use different strategies, but this space inside the shape is the same. It did not change. And what is that space called?
Yeah.
So, this strategy took probably a little bit while longer, right? Because you had to make all of those columns. Whereas this strategy maybe was a little bit quicker. But both strategies found the space inside of this shape. And they found the space inside by using what they knew about rectangles to break it up, and then using what they knew about area to multiply or add and find the space inside. Okay? I'm going to leave you guys with that because I know we have to go. We're going to pick up with this on Friday, Thursday. Okay? All right. Oh, okay, yes, you're right. You guys did an awesome job today, being mathematicians. So, here's what we're gonna do. Roller coaster cheer, get ready. No, slow back down. Roller coaster cheer, get ready. Go. Awesome job today. All right, give yourselves a round of applause.